This week's session is going to be about 2D meshing and some of the tools that you can use in 2D meshing. Certainly not meant to be exhaustive in just 15 minutes. So let's go ahead and get started. I'm going to open the HyperMesh model. I will send these after the class, and the recording should also be available to you after the class. And we'll start here with just a mid-surface geometry file. So we look at this part, and the first thing I notice, there's a couple holes, some slotted holes, and some lines that are pretty close together. I imagine my mesh size is going to cause a problem with some of these lines. The easiest way to tackle some of these issues is going to be fixing them in the geometry first. So let's go over here and look at some of these new defeaturing tools. Very easy to use. I can do a batch cleanup. There's not a lot of issues here that are going to be taking care of this, but if you have like this, a lot of very small lines relative to your mesh size, we can specify what we want the target element size to be. I'll leave it as 5 for this model. Specify a few things here. If you want to remove certain edge fillets below a certain radius, you can specify that. But for now, I'm going to select all the surfaces and ask it to do an auto cleanup. You'll notice that these lines that are very close together have been suppressed. They're in that dotted blue line, meaning that we're just going to ignore them when we mesh and pretend like it's not there. We could have also done that through this tool in the stitch icon that we talked about last week. And let's say I also want to get rid of one of these holes. Maybe in the case of other models, the holes are very small and they're going to cause problems with the mesh. So we can ask it to find all of the holes. There's certain diameter options that you can specify here. So I've set the maximum to be 20. And I can either say remove all, that'll remove all the holes it's found, or I can come in here and just manually select and make them go away. It's not going to find these holes that are not round, I don't think, or maybe my tolerance just wasn't high enough, but there's other ways we can fill this in. If I wanted to get rid of one of these, I could use this patch tool under the surfaces. Select what I want to get rid of, fill in, and maybe I don't want this outline to end up in the mesh, so I can come in here and suppress these lines. And that way it'll just mesh as if that box isn't there at all. Oh, so I ended up getting rid of both of those holes, I guess, but that's fine for what I'm showing. So going over to the mesh, all of our meshing tools are going to be grouped either here in mesh to get started, or elements if you want to go in and do something to that mesh later on. So we'll start off in the 2D general mesh, select the surfaces that we want to mesh, select our mesh size. If you're used to having all of those different options that showed up in the panels, you can always get to them from this drop-down menu on the side and start specifying some of these more advanced parameters. But a lot of people don't go in nitty-gritty and change all this stuff, so they're hidden from the user just for simplicity reasons to start with. So we'll hit mesh, and automatically when it meshes, we're going to go into this interactive mode. If you use classic HyperMesh, this is that bright green mesh that used to show up, but now it's a little more interactive. So we can click here and maybe select multiple lines if we want to increase the density. Maybe I want to increase so that there's 78 elements along here. We can also specify this by element size. So if I wanted to make this element size 4 units, then it's going to automatically adjust the density to 83 along here to make sure that we hit an element size of 4. Other tools in here, we can go to biasing, basically just telling us how the density changes along this line. So if we increase it, we end up with a higher density of elements over here and a lower density over here. We can also do this face edit to change what element types are used in certain surfaces. So right now I just have mix, but I could go over here and select maybe trias only, and then have it fill in just with tria elements. All right, so if I wanted to go in and actually edit some of these elements, I could come here and I get a whole drop down of different options for how to edit these. Before we also were in that, when after we meshed, we saw that it takes you to this quality. So you can quickly see at a glance what elements are failing our quality criteria, so we can focus our attention on those elements. Let's say I wanted to try splitting this. So I can split that, what used to be a quad, into two trias. I can also do things like move this node dynamically, and it will, by default, keep you in the plane so that you're not shooting that node out in some way that doesn't make a lot of sense. I can also replace nodes. So maybe I want to move this node here and collapse that tria element. It's going to warn me that I am replacing or destroying an element. So I'll say yes, continue, and now this becomes a quad element. In this move tool, I can also select trias and just on the fly move them to somewhere else. You'll notice that things do happen there along the way, so maybe don't move your tria elements too far. All right, so this is pretty straightforward. The mid surface is clean and the elements, it's relatively easy to mesh. And we went through and we at some point would have mid-surfaced this or brought this in as a surface from CAD. Not every part is going to be so straightforward to get a nice clean mid-surface out of and then put a mesh on that. One possible option for us in situations like that, I'm going to open a different model. And this is some kind of injection molded plastic part, pretty complex. I mean, if we were to go in here and mid-surface it, you'd get a lot of disconnected surfaces that needed to be cleaned up through a decent amount of topology repair. One possible option here is just to bypass the mid-surfacing part of this altogether and use this direct mid-mesh. So from this tool, I'm going to stay in automatic, select the component that I want to do the direct mid-mesh on, choose my mid-mesh, and click mid-mesh. Depending on the complexity of the part, this will take either more or less time to run. In this case, this is decently complex. It will take a little bit of time to run through this. We usually recommend, even if you want a relatively coarse mesh, to use a finer mesh to start off with. It'll take a little bit more time, but it's able to better capture some of the details and the transitions here rather than trying to capture this with like a 10 unit mesh size. Another thing that's a little bit different here from HyperMesh in the classic version is that immediately when you go into the meshing tools, you get this scale here to give you some idea of what a good mesh size would be instead of you going in having to measure it if it's a part that you're not familiar with. All right, so first thing we notice here, the geometry part of this has been switched to more of a transparent view, and we have this mid-mesh edges here. I don't personally love this visualization all that much, so I usually opt to come in here and turn that off. So one of the first things that I would probably do here is make sure that things that look like they are connected are actually connected. We don't have any kind of coincident node situation where things are just sitting on top of each other and not connected. Let's go here to, if I can't remember, for instance, where the edges are, we can look and it will take us back. You'll notice not every tool from Classic has been migrated over to one of these icons. Sometimes you'll click on them and it will take you to a panel. We'll select the component we're interested in, specify a relatively small tolerance because we don't want to accidentally take this node and this node from the element and try and collapse them onto each other. My tolerance of 0.1 for an element size of 3 is probably appropriate. And we're just going to come in here and say preview equivalence. In the status bar, it says 0 nodes were found. So there's not any nodes here that are very close, but just not connected. I'm going to turn this off. Come back. And now I can start to take a look at some of the issues that came out of this. Certainly, we're not going to be able to fix everything in 4 minutes, but just to give you a general starting point. So let's try. We've got a couple other issues over here. If I want to just select and delete some elements. Okay, we seem to be back on track. Now, maybe I want to fill in on the fly an element here. I can just click. If I wanted to make a tria, I could go ahead and left click and I'd make a tria element, but we're going to go ahead, fill that in with a quad. Again, maybe I want to split this into trias. Get out of this tool. Come in here and delete this last little element fragment. No problems this time. Something else that I notice here that I'm going to want to fix is there's this kind of weird bump transition area, and I really want this to be flush with the rest of this part. So within my Midmesh tool, this is something that happens kind of often, so it's grouped here. I want to align these elements with a surface. So I'm going to select these two elements, use this surface as my guide, and hit align. And these are back where they should be. That's a real small sliver element. I'll probably want to fix that as well. But in the interest of time here, I'm going to show one more feature, which is this map thickness tool. So not everything in here is the same thickness. These ribs here are a different thickness than this. So rather than having to go and create these manually or just kind of giving up and assigning the same thickness to everything, we can use this map thickness tool. So we're going to select the source, which is the original geometry, the target, which is the elements that we're going to assign the thickness to, and we're going to say apply thickness. What this is doing is coming in here and at each section calculating the thickness, making a P-shell property and assigning that P-shell property not to the component, but directly onto the elements themselves. That issue for me yesterday, and I'm working with a new machine. So fortunately, all is not lost here. It was able to create those properties. And if we go in and ask for the display to be by thickness, you'll see that we've got, it's easier to see here, a range of thicknesses that have been created. And we can also turn on this 2D display as 3D to see, are those thicknesses that it created reasonable? So I can see this purple property, this red property. These are very nicely matched up to the thicknesses that correspond on the part itself. If you're spot checking, you don't have to accept everything that it takes. You can always select here, right click and assign and select elements instead of components. You can select elements and assign a certain thickness to them. Another possible option here, if you think, oh, 22 properties per component is really a lot to manage, you can go in and when you do this operation for the map thickness, you have the option here to say, maybe I only want thickness changes if there's a big enough threshold. So maybe I'll change that to 1, and then I'll get less properties created. So I wouldn't have a thickness 1.028 and 1.09. Maybe that's not enough of a difference for me to consider. And one thing to note, this map thickness doesn't only work with the direct Midmesh tool. You are also, of course, welcome to use it on the more traditional workflow of going from a solid to a mid-surface to a mesh. Same thing applies. You would just select the original solid, select the elements to map to, and you would get the same end result.